Here we have LeetCode problem number 53, maximum subarray, which is a nice and simple medium LeetCode problem, but once you get the hang of it, it's not really that bad. Basically, you're given an integer array of nums, and you want to find the subarray with the largest sum, and then return its sum. So before we get into it, what is a subarray? Subarray is just a continuous piece of an array. So like these three elements here could be considered a subarray. So -2, 1, and -3 is a subarray. Continuous piece of an array. It could even be a single element, like just 4. That's a subarray of this whole array. Or it could even be the whole array. That could be a subarray too, right? But remember, it has to be continuous. So it can't be just like -2 and 1, and then also like 4 and -1. That's two subarrays. That doesn't work. You can't return two separate subarrays. It has to be a continuous piece of an array, right? So just visually, how would we find the subarray with the largest sum? We would essentially just look for the piece of the array with the largest numbers, a continuous piece of the array with the largest numbers. So you can do some addition in your head. You could just like try to add them all up, see what happens. You could try to add up. You could look, after a little while of looking at it, you can notice, okay, this area of the array here, these 4 elements, when you add them together, they give you the largest possible sum, which is 6. Sum of these 4 elements is 6, right? So in this case, how did we do it visually? We just looked at it and we just, did a bit of guessing and checking, and we just saw, okay, this has the greatest numbers. But how could we do that in code? One way to do it is a very terrible solution. It's an O of n squared solution, and all you just do is 2 nested for loops, and then you check every possible subarray. So you start here, start at the beginning, check this subarray, you check this subarray, check this subarray. You keep going until you check every possible subarray involving this one, right? Then you keep track of this total, the max total, right? And then you would iterate the outer for loop, and then you would continue checking every single subarray over and over again with 2 nested for loops. That's an O of n squared, and it's really slow and really bad. So how would we do it in O of n? If it's the first time solving this, it might take you a little while to think about how to solve it, but once you've seen it once, it really isn't that complicated, and it should be somewhat intuitive. Basically, for O of n, it's just one single for loop, and before we do that, before we even make the for loop, we want to initialize and declare 2 variables: one current total and current max, right? So before we enter the for loop, we actually want to set both current total and current max to the first element, right? And then we actually want to have the for loop start here at index 1. So then in the for loop, we're going to have 2 conditional statements, right? The first one is going to be checking, is the current element, in this case 1, is that greater than the current total, which is -2, plus the current element, which is 1, right? So is 1 greater than -2 plus 1? It obviously is. 1 is greater than -1, right? So in that case, all we have to do is make the current total equal to the current element. And the reasoning behind that is this current element will be greater than any possible subarrays previous to it because of that calculation we just checked. We know the current total. We know that the element itself is greater than the current total plus the element itself. So in that case, the current element is greater than any possible subarray previous to it. So we can just continue moving the loop forward while sleeping well at night, knowing that okay, if we want to find the maximum subarray, we can disregard the rest based on hitting this condition in the if statement. But there is also an else to that if statement. So if this wasn't true, all we would do is we would just add to the current total. We'd add the current element to the current total, which you'll see in later cases as I iterate through this test case. Alright, so also that's the first conditional statement in the loop. And the second conditional statement is just updating the max. So if the current total is greater than the current max, we just set the current max to the current total. As simple as that. Simple. Another simple conditional. And now after those two conditionals, you're ready to iterate through the loop. So now we're on index 2, right? And we want to do the same checks, the first check, the same two checks. First, we want to check, is the current element minus 3 greater than 1 plus minus 3? So 1 plus minus 3 is minus 2, so minus 3 is not greater than minus 2, right? So in that case, you hit the else, right? So if you hit the else, all you do is you add the current element to the current total. So how would we do, in this case, if we add minus 3 to positive 1, which is the current total, we would get negative 2. So I'll erase this first, and then I'll update the current total, which is now negative 2. Current max, it hits this conditional. Is the current total greater than the current max? No. So the current max stays the same. So currently the subarray with the largest sum is this, right? It's just 1. But we haven't finished checking the rest of the array. So the loop iterates forward. Boom, it hits 4. So is 4 greater than the current total, which is minus 2 plus 4? Obviously 4 is greater than minus 2 plus 4, so in that case, if the condition is true in the first conditional statement, what do? We just set the current total to the current element, and we know we can sleep well at night knowing that any other subarrays previous to this will not have a greater sum than 4, which is the current element, based on hitting true in that conditional statement. Obviously, you want to update the max if it's greater, so in this case, the max becomes 4. And then iterate forward. Boom, we're at minus 1. Is minus 1 greater than 4 plus minus 1? It's not, so all we do is we add the current element to the current total. So I'll go ahead and do that right now. 4 plus minus 1 is 3. And then the max stays the same. The max is still this subarray. And we continue. We're here at 2. As the loop iterates, we're at 2. So is 2 greater than 3 plus 2? Obviously, it's not. So in that case, we just add the current element to the current total. So it'd be 3 plus 2, which equals 5. And then what do you know? Then max becomes 5 because 5 is greater. So the max subarray is now this, right? So now the loop iterates forward. We're on 1. Same thing. Is 1 greater than 5 plus 1? Obviously it's not, so we just add the current element to the current total. We don't reassign the current total. So I'll erase that. I'll make this 6. This becomes 6. Oh. And as you can see, we have our current max, which is what we're going to return, and 6 is actually correct, right? But obviously the loop isn't going to stop there. It's going to continue checking the rest of the possible elements. So in this case, the current max is this subarray, which is correct, so we would return 6, right? But as the loop has to finish, it's an O of n solution where n is each element in the array. So the loop continues, and it'll do the same check. Is minus 5 greater than 6 plus minus 5? It's not, so all we do is we add minus 5 to the current total. After I erase this, it's getting a bit messy. So 6 plus minus 5, what do you know? That equals 1. Max, no, we don't update the max, we just have 1 there. Now we have 4, is 4 greater than the current total plus the current element, which is 4, is 4 greater than 5? It's not, so what do? We just add 4, add the current element to the current total. So it would be 4 plus 1, we'd have 5 again. And then that's it, the loop is ended. We loop from here to here. I guess it would actually be, the loop would actually be O of, the time complexity would actually be O of n minus 1 because we started here, and n is the rest of the elements of the array. So yeah, we would return the current max. So this takes quite a while to explain, especially if I go, since I went through such a long test case, but I hope that gave you a better understanding, and now we're just going to go ahead and code it in Java. Alright, so here we have the LeetCode problem open, and basically I'm just going to start coding it in Java. So remember, as based on the explanation, the first thing you need is to initialize two variables, and they're both going to be integers. The first variable is going to be int current total, and as I said, you want to set it to the first element of the array, which is nums at 0. Then you want to do another integer called just called max, I guess. It doesn't really matter. That'll just be what you return. It's going to be the return maximum sum of the subarray. So you want to also set this to nums at 0. The reason we want to set it to the first element is nums is because we're going to start the loop on the second element, or the first index. So as I said, for this solution it's O of n, and it's going to be a single for loop. So we're going to do for int I equals 1. We want to, since we have the set to the first element, we want to start on the second element, so I has to be 1. I is less than nums.length, and then I plus plus. So in the loop there has to be two conditional statements. The very first conditional statement will be checking if nums at I, which is another way of saying the current element, if the current element is greater than the current total plus the current element, which is nums at I. If this is true, what are we saying? If this case is true, we're basically saying, okay, disregard the previous current total, everything at the current total and behind that, we can disregard that, because we know that the current element is greater than any possible previous sum arrays in the array. So what would we do? We would just set current total. Oh, sorry, can't spell today. We would just set the current total to the current element, nums at I, right? But what if this case wasn't true? That means we need to still consider the subarray that contains the previous elements. We can't just disregard it and start fresh at the current element, right? So else, all we do is we add to the current total plus equals the current element. We just add to the current total and we continue working with that current total, which it has some of the previous elements in it, right? So that's it. That's simple enough for the first conditional. And then the next conditional statement is even simpler. We just want to update the max. So if cur total is greater than max, what do? We set max to the current total. Simple as that. Current max equals current total. And that is pretty much it. That was a very long explanation earlier for some very short and simple code, but it's really good to understand the problem instead of just looking at a short loop and copying it. So that's why the explanation was so long. So then obviously what do you return? You return max, and this should solve the problem. Unless I had some syntax errors. Num.length. So I really butchered the spelling there. Length. There we go. Boom. Everything seems to be working fine. We can submit this, and this is a O of n solution, so the time should be quite fast. Yep, 1 millisecond. And there you go. So if you enjoyed this video, if you enjoyed the explanation, and if it helped in any way, please go ahead and subscribe to the H3K channel. I would really appreciate that. And go ahead and leave a comment if you didn't understand anything. Thank you.